Welcome back, dear students. So today we are going to learn very important topic as per your IC syllabus. Okay, and the topic for the day is properties of determinants. Okay, now the properties are given in the screen right now, and I expect that the very same things are there in your formula book as well. Okay, so let's see one property at a time. So for any square matrix A, okay, so you take any square matrix A. So this is square matrix, then its determinant, all of you know, is represented by this. Yes. Now if I ask you, so we are learning the first property. Now if I ask you, if A is the square matrix, what will be its transpose? You say its transpose will be A dash, isn't it? Now if I ask you to find the determinant of this, the value of this determinant will be equal to this one. Okay, so that's the only thing that you need to understand. Okay, so for example, if I give you any matrix A, okay, so for example 1 minus 1 2 3, okay, then its transpose obviously will be A dash, right? So A dash will be, see here carefully, so 1 2 becomes the rows and you get minus 1 3 as the second row. Okay, now this is A, this is A, this is your A dash. Now I want you to find what is your this one, and from here you find what is your determinant of this matrix. You will find that these two will be equal to each other. Okay, so this is the first property. Okay, so let's see the second property. So second property says if we interchange any two rows or columns, then the sign of the determinant changes. For example, let me take this determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is the given determinant. Okay, so if I interchange any two rows or column, okay, so let me change the rows. For example, let me interchange these two. Okay, so if you interchange, this goes out here, so you get A2, B2, C2. Okay, and this comes here, that is you get A1, B1, C1. Yes, and the last one is kept as it is. Okay, now when you interchange, the sign of the determinant changes. That means here we don't have any sign, but there has to be plus, right? Now when you interchange any two rows only, I'm talking about only two rows, then the sign changes. That means this plus becomes minus. Okay, in the same way you can change column also. For example, if I change these two column, if I get this here and if I take this over there, again the sign will change. Okay, so that is the thing that you need to keep in mind. So this is my property number 2. Okay, let's see the third property, which says if any two rows or any two columns are identical or proportional, then the value of the determinant is 0. Okay, so let me explain you using this one. 1 2 3 4 5 6 7 8 9. So let me call this. Okay, okay, just wait a minute. Okay, so let me take this one, 1 2 3. Now in this determinant, what can you observe? You observe that first row and second row are identical, isn't it? So in such case, see, this thing can happen in the columns also. Okay, but I am just showing you using the rows. So if any two rows are identical, then the value of this entire determinant will be equals to 0. Okay, or if the rows or columns are in proportion means, okay, so let me write 2 4 6. What is the ratio of this and this? Isn't it 1 by 2? Yes. What is the ratio of this and this? 2 by 4, which is again 1 by 2. What is the ratio of this? This is again 1 by 2. Okay, so the ratio of this and this, they are turning out to be equal. So in such case, these are known to be in proportion, right? So that means I say that 1, 2, 3 and 4, 2, 4, 6, they are in proportion. That means these two rows are in proportion. So in such case also, your value of the determinant becomes 0. Okay, so that's the thing that you need to keep in mind. So this is my property number 3. Let's see the next property, which says if we multiply each element of a row or a column by a column of a determinant by a constant k, then the value of the determinant is multiplied by k. Okay, so this means, see, the thing is very simple. Okay, so there's a determinant, let's say this one. Okay, so if I multiply one row, okay, it can be anything. Okay, so we have a1, b1, c1, let's say a2, b2, c2, a3, b3, c3. So let's say that there is this determinant. Okay, now if I multiply this determinant by a constant k, remember in case of matrices what we used to do, if I multiply with a constant, we used to multiply to each and every element in case of matrices, right? But in case of determinant, what happens is you cannot multiply all the elements. Okay, so you can go for either one row or one column. That means if I choose this row, if I like this row, then I can multiply this k to only this one. So in that case, this becomes a1, b1, c1. So if I multiply this entire thing, this becomes k a2, k b2, k c2, and the last one will remain as it is. So that's the meaning of property number D. Okay, and property E also means the same. Okay, so next is there's a matrix A. Okay, and after multiplying matrix with a constant k, okay, there's a matrix C. There's a difference between this and this. I'm multiplying a matrix by k. I'm multiplying here a determinant by k. Okay, so there is a difference. Now after multiplying with k to a matrix, after multiplying find the determinant. And let's say you can find the determinant only of square matrix. So let's say the order of the matrix is n cross n. Okay, the order of this matrix is n cross n. Then in this case, this will be equals to k to the power n into determinant of A. Okay, so very important property for your objective questions. Okay, so this is your next property. Now let's see another one, property number G, which says if elements of a row or column in a determinant can be expressed as a sum of two or more elements, then the given determinant can be expressed as a sum of two or more determinants. Now see, just reading won't help you, you won't be able to understand. Let me explain you using the examples. For example, let me take this determinant a1 plus b1, let's say a1 plus okay, so just let's take k1. Okay, b1 plus k2, c1 plus k3. Let's see this one. So a2, b2, c2, a3, b3, c3. So basically, as per the property, what we can do is you keep this a1, b1 and c1 as it is. So a1, b1, c1, others will also be kept as it is. Okay, all right. Now what happened to k1, k2 and k3? Here we have plus sign, isn't it? So you have to write plus here and see here carefully, and I can do the same out here. So here we have already written a1, so k1, k2 and k3 are left in the first row. Other rows will remain as it is. That means you have to write a2, b2, c2, c2, a3, b3, c3. So that's the meaning. I hope this thing is clear. Okay, now So these are the things that you need to keep in mind. Very important property when we solve the problems in determinants. Okay. Next we have the last property, which is if to each element of a row or a column of a determinant, the equimultiples of the corresponding elements of other rows or columns are added, then the value of the determinant remains the same. I know you did not understand this, so let me explain you using the example. For example, let me say there is a determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Let's say there is a determinant. Okay. Now, what am I going to do here is I'll do. Okay. So the value of this determinant will be equals to. So we have A1 plus. Okay. So let's say K A2. Okay. I am taking, see, for this row. Okay. Instead of this row, what am I doing is I am taking this row equals to basically this operation. I am talking about row 1 is equal to, if I do row 1 plus K into row 2. So if I do this operation, what happens is, you see, K R1 is written as R1, that is A1 plus K A2. Okay. Similarly, we have B1 plus K B2 plus, I'm sorry, last one, C1 plus K C2. Okay. If I do this operation, then the value remains the same. That's what the question is saying. Okay. So basically you are changing only row 1. So we'll keep row 2 and row 3 as it is. Okay. B3, C3. Okay. So the value of this determinant and this determinant remains the same. That's what the property number 8 says. Okay. So having understood about these many properties, let's see few problems from your exercise. Now let's see the properties that we have learned just now in order to solve some problems. Now the problems where you need to apply properties will be given in this format. They say without expanding. Okay, that means without expanding means you have to apply the properties which you have learnt. So without expanding, find the values of these. Let's see how to do this. Okay. Now in such kind of questions where you will be asked to find the value, most of the time your answer will be 0. Most of the time. Okay. Let's see how. Now here, what am I going to do is, from all these, can I take 7 common? Why? Let's see. Not 7, just wait a minute. Can I take 6 common? Let's see. Okay, so if I do that, okay, so basically in other words, what am I trying to do here is, I am going to see whether 2 rows or 2 columns are proportional or not. Okay, now I say these two must be proportional, because see, now 102 by 17, if I find that, this will be equals to exactly 6. Similarly, 18 by 3 is also 6 and 36 by 6 also 6. So basically they are proportional, right? So in such case, what am I going to do is, I will write this as 6 into 17. I will write this as 6 into 3, and I will write this as 6 into 6. So others will remain as it is. Okay. Now in the next step, if I call this as constant k, that can be taken outside using the property, remember. So this is k, that's k is 6. So 6 into this determinant. So what is left here? 17. From here 3, here 6, and the others are 1, 3, 4, 1, 3, 4, and the last one is 17, 3, 6. Now as you all know, if any two rows are identical, then the value of entire determinant becomes 0. So that's why this is, so constant 6 into the value of this is 0. So 6 into 0 is 0. Okay, I told you that in such kind of question your answer will be 0 only. Now let's see in this case. you try to find the row or columns which are in proportion, but I am not able to find the rows or the columns which are proportional. And I told you most of the time the answer is going to be 0. So in such case you can apply your row operation or column operation. So basically here what am I going to do is I will do this C3 to be C3 minus C1. If I do that, let's see how much do we get. So we get, okay, so if I do this operation, you get, see you are changing C3, okay. So C1 and C2, column 1 and column 2, they will remain as it is. So you get 2, 3, 5, you have 7, 8, 9. So C3 minus C1, that means this minus this is 63, okay. This minus this is 72, this minus this is 81. Yes or no? Okay. Now, are these two proportion? Yes, isn't it? So basically what am I going to do is, so we have 2, 3, 5. Please do not get confused with this broken part, okay, the board is broken. So 2, 3, 5, we have 7, 8, 9. Now can I write this as 6 into 7? Can I write this 72 as 6 into 8? I'm sorry, 9, not 6. This is 9, yes. And can I write this 81 as 9 into 9? Yes. So this 9 becomes my constant. Can I take it outside? Yes. So this is common, 9 is common to this row. So if I take this out, you get 9 into, so we have 2, 7, 7, 2, 7, 7. Next we have 3, 8, 8, 3, 8, 8. Next we have 5, 9, 9, 5, 9, 9. Okay. Now, column 2 and column 3, they are same, right? So that's why the value of, or identical, these two are identical. So that's why the value of this entire determinant becomes 0. So 9 into 0 is 0. Okay. So it will be better since two columns are C2 and C3 are identical, that's why the value will be 0. If you mention that, that will be even more better. Okay, so you may pause the video and note down your solution. Again, so question says, without expanding, find the value of this. I told you, your answer must be 0, okay, in many of the cases. Okay, so here what am I going to do is, see, it's your choice. Okay, once you are used to with the practice, then this kind of question is nothing for you. Okay, so what am I going to do is, now you know the value of the determinant will be 0 if the two rows or the two columns are identical or proportional. Yes, so I am going to use that only. All right, so here you see that nothing is proportional, no rows or no columns are proportional. So in this case, what am I going to do is, let me do two operations. That is, I am going to change row 2. So I am going to write row 2 as row 2 minus row 1, and I will write row 3 as row 3 minus row 1. If I do that, let's see what happens to this determinant. So then first you write that, okay, and that will be equals to, so you are not changing row 1, so let me write row 1 as a plus b, 2a plus b, next is 3a plus b. Okay, row 2 minus row 1, that means 2a plus b minus, let's see, okay, so 2a plus b minus a, okay, a plus b. So when you subtract, you have to change the sign. So 2a minus a is a, b minus b is cancelled, right? So this turns out to be, this minus this turns out to be just a. Okay, similarly we have 3a plus b, 2a plus b, and when you subtract, right, you are subtracting here, so again these two gets cancelled, so we get only how much? 3a minus 2a is again a, so this will also be a. Similarly 4a minus 3a is a, b minus b is 0. Okay, now row 3 is row 3 minus row 1, this minus this, so 4a minus a is 3a. Remember, b and b gets cancelled. 5a minus 2a is also 3a. 6a minus 3a is also 3a. Yes or no? Now see, row 2 and row 3, they are in proportion, right? So the value of this will be equals to 0 because the row 2 and row 3, they are in proportion, right? So you can write, since row 2 and row 3 are in proportion. Okay, pause the video and note down your solution. Okay, so this is going to be my last problem for the day. Question says, if A is a square matrix of order 2 and this is equals to minus 5, find the value of this. Okay, so basically here what you need to use is, you know, k into A is equals to k to the power n determinant of A, where n is the order of matrix A. Now in this case, what is the order? Order is 2, isn't it, right? So we have the value of k. What is the value of k? K is 3, isn't it? So we have 3a is equals to, so k to the power n, that is the value of n is 2, right, into this one as per this formula. Okay, I told you this is very important for your objective type question. So 3 square is how much? 9 into, what is this equals to? This is equals to minus 5. So that's why your answer turns out to be minus 45. Okay, let's see this one. Now similarly you have minus 5a. Okay, so k is minus 5, so this becomes k to the power n, the order is 3, right, into this one. So you know, minus into minus cube is minus only, 5 cube is 5 into 5 into 5, which is 125, into determinant of A is minus 2, right? So minus into minus becomes plus, 125 into 2 is 250. Okay, I hope this thing is clear to you. So with this, we close for the day. Thank you very much.